In this video, I want to look at a few examples of orders where we are asked to administer medication via IV push. So as we saw previously, or have read, IV push is a procedure where a patient will be administered medication via an injection, but it's an injection into a port that is already hooked up for either a maintenance or a secondary IV. So this is where a patient's receiving an IV via a pump or some other way, and there's a port where we can put in and inject medication into that port. And it allows patients to feel the effects of the drug right away. Now there are a few things that are really important when we are doing and calculating dosage for IV push. One is we need to be conscious and need to look for information about the injection time. So it gives you instructions, or you should be provided instructions about the injection time, whether it be a ratio, don't exceed 4 milligrams per 5 minutes or whatever. It's going to be different for each problem. So we have to read into the problem and see if we can find that information. If we look at this problem, our order is for this drug. I'm not even going to try to pronounce it. But we need to give 7 milligrams via IV push right now. This drug is available 2 milligrams every milliliter, so that's the strength of the drug. We look at the reference, and it says that this drug needs to be administered every 5 milligrams, needs to be administered over 3 minutes, and it's going to be into the Y point, the Y site of an IV. So it also gives some information about what we should look for if we are administering the drug too fast. So the first question says, how many ml would you administer? So very similar to our injection problems, we'll be filling a syringe. So what we need to think about is how many milligrams the patient needs to receive and look at the strength of the drug. And that's going to tell us the number of milliliters to fill the syringe. So this is just a one-step dosage conversion. I see that the patient needs to be given 7 milligrams. The strength is 2 milligrams per milliliter. So I'm using dimensional analysis, and I see when I divide those 7 by 2, I get 3.5. So I would fill the syringe 3.5 milliliters of the drug. You could also use a proportion, or you could use the nursing formula, but you should arrive at that same value of 3.5 using what needs to be administered and the strength of the drug. Now we need to look at Part B, where it says using the recommended rate of administration, which is in this case the injection time. We need to determine the number of minutes and seconds that we should be standing there and pushing this medication in. So sometimes you'll be standing there and actually physically pushing the medication over a period of a few minutes. So look for, in the instructions or on the label, look for information about a rate of administration or injection time. And I see immediately that each 5 milligrams needs to be administered over 3 minutes. So that is the rate that needs to happen. 5 milligrams over 3 minutes. Each 5 milligrams should be administered over 3 minutes. Now ask yourself, how many milligrams are we administering? Are we administering 5 milligrams? Because if we are, then we're done. It's just 3 minutes. But we're not, right? We are not administering 5 milligrams, we are administering 7 milligrams. So oftentimes in these problems, I like to use ratios and proportions instead of dimensional analysis because it aligns, at least from my perspective, aligns a little nicer. We see here we're administering 7 milligrams, not 5 milligrams. So this is the rate that must happen. This is the invariant relationship between milligrams and minutes that must happen. This is the number of milligrams that we're administering. So we need to now look at this and solve for x. And I'm going to cross multiply here. And I get 3 times 7, which is 21. And on the right-hand side, I'll get 5x. So when I divide both sides by 5, 21 divided by 5 is 4.2. And that's going to be equal to x. So what we get is 4.2 minutes. So that's good. We have 4.2 minutes. That's how long we'll be standing there and slowly administering the medication into the Y site. Now, you're asked to find minutes and seconds. So we're going to have 4 minutes, but we want to convert the 0.2 minutes into seconds. So I can do that by, and we're talking about 0.2 minutes. That's 2/10 of a minute. So if I multiply that by 60, 2/10 of a minute, because this is 60 seconds, then I will get 12. So this will be 4 minutes and 12 seconds. If you're a little unsure of what I did right there, you could always just set up a proportion. You know that 1 minute is 60 seconds. And what we want to know, if that's the ratio, that is the relationship between those two units, we want to know how many seconds, so how many seconds, x seconds, is equivalent to 0.2 minutes. So this is the proportion that we could solve, and you could cross multiply, you could look at the invariant or covariant relationship between them, and you get 12. So we just calculated that this patient needs to be receiving the medication over a period of time of 4 minutes and 12 seconds. Let's look at one more example. In this example, we are administering Enocor 60 milligrams. This is going to be an IV, and it's going to be over 2 minutes. So right off the top of the bat here, we see that the injection time, this needs to be administered over 2 minutes. So it's a little bit different than the last problem. What is available to us is this drug at a strength of 100 milligrams for 20 mLs. So similar to the last problem, we know the number of milligrams the patient needs to be receiving, and we want to use the strength to figure out, well, how much are we going to be filling the syringe? So I'm going to use dimensional analysis here, just like we did in the last example, and I'm changing my 60 milligrams into an equivalent number of milliliters. This is a one-step dosage conversion that we have seen throughout this course. And we should get, when you multiply 60 times 20 and divide it by 100, you'll get 12. So this is 12 milliliters. So we just converted 60 milligrams into an equivalent number of milliliters using the dosage strength. And we see that the patient needs to be receiving 12 milliliters. So we would go grab our syringe, pull back 12 milliliters, and now I need to think about, okay, how fast do I need to be injecting this? And we're specifically given the time in this example. So it's a little bit different than what we saw in the previous example, where it's not giving us a recommended ratio, but it's specifically in the order stating use or inject this over 2 minutes. So for part B, at what rate in milliliters per minute should we administer this dose? Well, if we're looking for a ratio of milliliters to minutes, I know the total number of milliliters that are in the syringe that will be administered, that's 12 milliliters, and I know the total number of minutes that I will be standing there and pushing medication, and that's over 2 minutes. So this is similar to how we calculated unit rates when we were doing our first IV calculations, and we were asked to, 500 milliliters needs to be infused over 4 hours. We just looked at the quotient. We looked at 500 divided by 4. The same thing is true for this. 12 milliliters over 2 minutes. When you divide 12 by 2, you get 6. So this is 6 milliliters every minute. You can see how this problem is different from the last problem. And what we find is many of these problems are quite different, these IV push problems. Oftentimes you're told, just like in this example, administer over this amount of time. Other times you have to look at the literature or the accompanying order or information with the order or on the drug label for information on how to administer and the rate of administration.